Okay, so year 12, for today we're going to be continuing with partial fractions, but we're going to be looking at a really specific type of partial fractions. So we're going to be looking at fractions which has got a repeated linear factor in the denominator. So for example, and this is kind of a general form, imagine we had something like this, px plus q over, let's say, ax plus b squared. You might want to try and write that in this form, a over ax plus b over ax plus b. But that's not going to work. And the reason that this isn't going to work is because we've got these fractions here have got the same denominator as each other. Your whole simplification process is going to go wrong. You'd end up with something like px plus q over ax plus b squared equals this, which isn't what we want. We won't have split it into partial fractions. However, and this is like the general principle, and it'll all make a lot more sense once we've done like an actual example of it, is this. Any fraction that's in this form, px plus q over ax plus b squared, can be split into partial fractions in this way, a over ax plus b over ax plus b squared. Okay, so the linear factor gets repeated with one of the times it being like the squared version. We'll go through like a couple of specific examples of that now. I know that's all quite abstract and a little bit weird, but it should make quite a bit of sense once we've done the first one. Okay, so then first actual question, express this in partial fractions. Here we've got 9 over x minus 2, x plus 1 squared. Now to split this into partial fractions, it's going to have 3 different fraction parts to it. So it's going to be a over x minus 2 plus b over x plus 1, and then plus c over x plus 1 squared. That's the form it's going to split into. So this x plus 1, because it's squared, we have it as a single linear factor and then a repeated factor here. That's super, super important. None of these questions will work if you don't get that bit right. So then after that, we do the same process that we've looked at already. So we would, with this fraction here, our common denominator becomes x minus 2, x plus 1 squared. Over here, we've still got this. Thinking super carefully, to get from this x minus 2 to x minus 2, x plus 1 squared, I've multiplied by x plus 1 squared, so I get x plus 1 squared a. Thinking carefully about b, so I've multiplied b to get from here to here by x minus 2, but also x plus 1. So I get x plus 2, x plus 1, lots of b. And in terms of c, I've simply multiplied by x minus 2. So I get x minus 2 lots of c. So now it all looks like that. We get 9 equals x plus 1 squared a plus x plus 2 x plus 1 b plus, oh, that should be a minus 2, shouldn't it? That's just me not reading my handwriting properly. Sorry, that should be minus 2 there. And therefore it should also be minus 2 here. Okay, so now it looks like that we can make some substitutions. So the first substitution I would make, I would say that x is equal to 2. The reason, we'll go through the reason why I've said x is equal to 2, but first of all let's just say that x is equal to 2. When I substitute x equals 2 in, I'm left with 9 equals 2 plus 1 is 3, 3 squared is 9, so 9a. Then here 2 take away 2 is 0, so I get 0 lots of b. Here 2 take away 2 is 0, so 0 lots of c. So 9 equals 9a, and therefore a equals 1. After that, another good thing to substitute in would be x equals negative 1. Now when I substitute in x equals negative 1, here, this bracket, this expression will be equal to 0. So we get 0a. This will be equal to 0 as well, because minus 1 plus 1 is 0, so I get 0b. And over here, minus 1 minus 2 is minus 3, so minus 3c. And because of that, c equals minus 3. Now at this point there's kind of a couple of things that you can do to work out b. My recommendation is that you just substitute another number in. Choose like an easy number. So I'm going to substitute in x equals 0, and we'll just watch what happens when I substitute in x equals 0. I will get 9 equals, then I will get 0 plus 1 is 1, 1 squared is 1, so I get 9 equals 1a. Then here we would get 0 minus 2 is minus 2, minus 2 times 1 is minus 2, so you get minus 2b. And then here I get 0 minus 2, which is minus 2. So minus 2c. Now luckily, because we already know what a is and we know what c is, we can solve this equation now for b. So to solve this for b, well, a is just 1. It's 1a, so that's just 1. Minus 2b. And then we've got minus 2c, which is minus 2 times minus 3, which is positive 6. So then, blah, blah, blah. 9 equals 7. Minus 2b. So if I take away the 7, oh, let me just move the paper a bit. If we take away the 7 from both sides, we get 2 equals minus 2b. And after that, b therefore is minus 1. Okay? And so now we've got that. We know a is 1, c is minus 3, and b is minus 1. We can rewrite this original thing as its partial fractions. So as its partial fractions, it's a over x minus 2. So 1 over x minus 2. B was minus 1, so minus 1 over x plus 1. And then C was minus 3, so minus 3 over, what is it, x plus 1 squared. And that's it. We'll do a second one now, just to try and clarify everything you need to be doing there. Okay, year 12, second example then. This one is probably as hard as it gets. So you've got to express this here in partial fractions. Now, because the denominator has been given to us like this, we'd first of all want to start by factorising the denominator. So if I look at my denominator, that will factorise to x squared, brackets 2x minus 1. Okay, so thinking really, really carefully then, when I rewrite this as its partial fractions, it is going to be a over just x. So x by itself is like one of the linear factors, because this is x squared, we need to use x. We also need to use x squared, and then we also need to use 2x minus 1. So that's how it's going to end up being written. So after that then, blah, 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 in terms of multiplying through, so the a would get multiplied by x and 2x minus 1 to get to this denominator here. So we get 2x minus 1 x, lots of a. In terms of our b has just been multiplied by 2x minus 1. And then in terms of c's been multiplied by x squared. So it should look something like that. And that is equal to the left-hand side, 11x squared plus 5x minus 4. So now it looks like that. We're going to make some substitutions. I would first of all suggest, let's substitute in x equals 0. That's a nice place to start. So when x equals 0, 0, 0, minus 4, so we get minus 4 on the left-hand side. Then a will be 0 because of the x here. C will be 0 because of the x squared here. And b will be 2 times 0 is 0, minus 1. B. So because minus 4 equals minus 1b, b is 4. After that, in terms of, we need to eliminate one of the others to find the other thing. Let me restart that sentence. We need to eliminate either a or c now. And to do that, we're going to make an appropriate substitution. So I would suggest we need to substitute in x equals a half, because if we substitute in x equals 1/2, this bracket becomes equal to 0, and then it is possible to solve. Now, where have I put my calculator? I don't have my calculator, so we're just going to try and do this without. So here we have got 11 lots of 0.5 squared, which is 11 lots of 1/4, so it's 11 over 4 plus 5 over 2 minus 4 equals, then this a will become equal to 0. Over here this b will be equal to 0, and then this c, when x is a half, would be worth 1/4 c. Now if I have my calculator as well, this would be super easy. Here we go. So if we have 11 over 4 plus 2.5 minus 4, we get 5 over 4 equals 1/4 of c, and therefore c equals 5. And finally, my recommendation is you just make another substitution now, and it doesn't matter what value of x you substitute in. I'm just going to substitute in x equals 1. So when we substitute in x equals 1, on this side we get 11. 11 plus 5 is 16. 16 take away 4 is 12. So on the left hand side I get 12. Then here, when x equals 1, this bracket is worth 1. 1 times 1 is 1, so we get 1a. Here, this bracket, 2 times 1 is 2, minus 1 is 1, so we get plus 1b. And then over here, 1 squared is 1, plus 1c. Now after that, we know then that b is 4, c is 5, blah, 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 blah. And therefore, a would be 3. And so to then write that in our partial fractions, we get 3 over x plus 4 over x squared plus 5 over 2x minus 1. And that's it. So this was the original question up here, 11x squared plus 5x minus 4 over 2x cubed minus x squared can be written as 3 over x plus 4 over x squared plus 5 over 2x minus 1.